Hello everyone, can you hear me? Okay, I guess I'm live now and you should be able to hear me now. Okay, how was your contest, guys? How was it? Mute myself. Was it good? How many problems you guys solved today? We should wait around three or 4 minutes until the rest of people join as well. If I want to tell you about myself, in this contest I solved all the problems, but I wasn't very fast. And I think my final score was not very good. I was 134. Hello. I see. Interesting. So I will tell you the solution of all the problems. Yeah, for the last two problems I had a little bit hard solution, and then I understood that I could simplify it. And if you want, maybe I can also overview the problems for you. I think the first few problems didn't have anything special. Problem D is interesting, kind of. I mean, there is a very neat solution for it. Penalty is your time, the time that it gets from you to accept the problem, plus for any wrong submission, you're gonna have an additional penalty. Sometimes in the contests it is 10 minutes, sometimes it is 20 minutes penalty. I mean, it will be added by 10 or 20. I'm not sure if in this contest it was 10 or 20. And right now, see if calculates 10 or 20, but there is some fixed amount of penalty for each wrong submission. Yes, yeah. Yes, C was also interesting, kind of. I mean, at its own level, it was interesting. And problem E, not very beautiful, but it was okay. F, F was just a binary search. I will tell you in detail when we get there. Yes, even without wrong submission you get penalty for, it depends on how long it took from you to accept that problem. G was kind of good, not very good, but good. H was a good problem. Yes. For problem D, for problem F, I think I used binary search. Yeah. Priority queue might, priority queue might help you to accept the problem as well, because at the end it's gonna be at most 2 times 10 to the 5th attacks. Okay, I think we're ready to start discussing the solutions. I think now it is the time. So let's start talking about the solutions. And hi Dimitri, by the way, how many problems you solved today? Some of you guys, I saw you in the previous streams as well, like Raim Kazi, if I pronounce correctly, Vazif, Dimitri. Let's start. Hi Angat, I Said. Let's discuss about the first problem, creating words. It says that Matthew is given two strings A and B, both of length 3. He thinks it's particularly funny to create two new words by swapping the first character of A with the first character of B. He wants you to output A and B after the swap. Note that the new words may not necessarily be different. But this is very easy. We just need to swap these two letters. It's just a simple code. I just did it like this. Maybe you can also use the swap function. There's no difference. I submitted this problem without compiling. I submitted the first two problems without compiling. On B, I got wrong answer on test 1. But on A, it got accepted. So, yeah. Anyway, it is just, for example, we say that character C is equal to A of 0. Then we set A of 0 to be B of 0. We save it in C because after this operation, A of 0 will be will have a wrong value in it. So we save it somewhere in character C and send B of 0 equal to C, then C of A and B. Okay. Is it clear? Shall we move on to the next one? You can react like this as well if you want to move on to the next one. Okay, awesome. Let's move on to problem B. Given an integer n, find an integer x such that x is from 2 to n, and the sum of multiples of x are less than or equal to n. Sum of multiples of x that are less than or equal to n is maximized. Formally, x plus 2x plus 3x and so on. Overall, x is maximized. I think I submitted a wrong code initially because I was very fast. I wanted to submit very fast. I submitted a wrong code, and that was why I got a wrong answer. This problem is very easy. We can just say that if n is 3, the answer is 3. Otherwise, the answer is always 2. Why? Because, well, first of all, you can have some intuition about the fact that these values, the number of these values is maximized when, for example, your number is 2. You know, when you have two numbers, I mean, if brute force is not necessary, yeah, because almost always the answer is 2, because 2 has so many multiples and many numbers. I mean, half of the numbers, all the even numbers will be calculated and will be summed up. There is only one special case for n equal to 3, because when n is equal to 3, we have only 1, 2 and 1, 3. 1, 3 is better than 1, 2. But when we have n is at least 4, then already we have two multiples of 2. Their sum is 6. And then nothing can reach 2 anymore. I mean, the next number comes, it's not a multiple of 3 as well. Then 6 comes, it is both a multiple of 2 and a multiple of 3, so it will be added to both. Then 7 comes, then 8 comes. For example, when we compare 2 and 3, then from here we are sure that always 2 is better than 3. Because 6 will be added to both of them, and again before 9, 8 will be added, and so on. And always 2 will have, in each 6 numbers, 2 will have one more number, which makes it way bigger than 3. The sum of multiples of 3, and even for other numbers. So the answer we can just say that the answer is always 2. There's just one very special case that if n is equal to 3, because we only have one multiple of 2, and also we have one multiple of 3 in this special case. In that case, the answer is 3, but otherwise the answer is 2. So we can just say that if n is equal to 3, C out 3, otherwise C out 2. Is this one clear as well? Shall we move on to the next one? Got TLE on H1 AC. We'll discuss that one. Okay. Next, problem C. Good prefixes. Alex thinks some array is good if there exists some elements that can be represented as sum of all the other elements. Now you have an array and you have to find the number of good non-empty prefixes of A. You have to find all the non-empty good prefixes. A prefix is good if there is an element that is equal to the sum of all the others. Well, it's very simple. We can just say that if an array is good, it means that we know that this one value should be equal to sum of all the other elements. What does it mean? It means that this is maximum, for example, and we have some total sum for all the elements. It means that maximum should be equal to sum minus maximum, right? Because it should be the sum of all the other elements other than maximum. Okay, and it's very easy to say that if some number is going to be equal to the sum of others, this number should be the maximum element, should be the maximum number. There is only the maximum number has the opportunity to be equal to sum of all the numbers, right? So the point is that only maximum can be that, because if there is another number greater than these elements, because all the numbers are non-negative, the sum of others will be obviously greater than that element if that element is not maximum, because there's only one element that is greater than this one. So it should be maximum. And maximum should be equal to sum minus maximum, or in other words, 2 times maximum should be equal to sum. So we can just run over all the prefixes and keep track of the current maximum and the current sum. Both are very easy to keep track of. We run over our array, keep track of the current maximum and the current sum, and whenever 2 times maximum was equal to sum, we just add 1 to the answer, and at the end we see how it ends. Does this make sense? Shall we move on to the next one? So the whole point is that the only thing that we need to check is to make sure that 2 times maximum of the array is equal to sum of that. Each time we are considering a prefix, when we're considering the prefix, it's easy to keep track of the maximum and the sum of the numbers. And then we can just each time say that if 2 times maximum was equal to sum, just answer plus plus. And that's gonna be all. Okay, Codeforces. Yeah, there was very long queues in this contest. I don't know, maybe many people participated today. Maybe in the 4 contests more people participate. I don't know. Is there anyone who only participates in the 4 contests or the 3 contests? Maybe there are more people who participate. Okay, let's now move on to the next problem. Given an n by m grid consisting of dots and hashtags, there exists a whole Manhattan circle on the grid. The top left corner of the grid has coordinate 1, 1, and the bottom right has coordinate n. And point AB belongs to the Manhattan circle centered at h and k if h minus a plus k minus b is less than r. If their Manhattan distance is less than r. Well, r is a positive constant. On the grid, the set of points that are part of the Manhattan circle is marked as hashtag. Find the coordinates of the center of the circle. And it is guaranteed that the whole circle is in our grid. So we have the whole circle, right? So there is a very easy solution. I just say that the answer is gonna be the average of all the cells. So if for all the cells you just calculate the average of their x's and the average of their y's, the middle point has that average value. For example, in here the middle point is 3 and 3. It's gonna be the average of all of them because everything is symmetric around it. Everything is symmetric around our center. So if we just calculate the sum of x's and the sum of y's of all these hashtags, then we can just divide that by their count, and that's gonna be the answer. Yes, we can also find the largest row and then find all the hashtags and report the middle point. But this solution is very easier to implement. I mean, it's very simpler, I think. Right? So it's just gonna be very easy if you just calculate the sum of x's, sum of y's, and the number of cells, and then the average point is gonna be our answer. So this is the whole code. So we have sum y, sum x, sum y, cnt. If s of I and j was equal to hash x, sum x plus equal to I, sum j plus sum y plus equal to j, cnt plus plus. And see out sum x over cnt. This plus one is for 0-based indexing and 1-based indexing. Everything is 0-based index in my code, but in the output they should be 1-based index. That's why I add 1 to it. So I will see out sum x over cnt plus 1 and sum y over cnt plus 1. You can disregard these plus ones. It's just I'm calculating average, and then that additional one is just for turning it to 1-based indexing. Right? Is this one clear as well? So in this problem, we can just simply consider all the hashtags, and between all of them, among all of them, just calculate the average points. And then the answer is going to be that. Shall we move on to the next problem? Use this reaction again if you are completely okay with this one. Okay, awesome. So let's move on to problem E then. Problem E, secret box. In here we have a box B with side lengths x, y, and z, and it's like in a 3D coordinate plane extending from 0, 0, 0 to x, y, z. Now you want to have a secret box S. You want to put it into this box such that it is parallel to all the x's. Every corner of S lies on an integer coordinates, and among all the possible ways to choose the dimensions of S, you should determine the maximum number of distinct locations he can choose to place his secret box. Okay, so first, for a second, assume that we know the size of this magical box. We know that the outside box has size x, y, and z. It's in 3D dimensions. It has 3D dimensions, and its sizes are x, y, and z. Assume that we know the dimensions of our magical box, for example. And for example, if this is x, or for example like this, we have, for example, x, y, and z. If we want to put inside of this box a box with size I and j and l, for example, then how many ways do we have to put it? How many distinct locations can we put it? If the size of this magical box is I by j by l, can anyone say that? If the size of this one is I by j by l, how many ways do we have to put this magical box into this box? How many different coordinates? Exactly what Razif says is correct. It is going to be x minus I plus 1 ways to choose that from which of these points you want to start in the x-axis. What is the starting coordinate in the x-axis? Because it can start from 0 to x minus I. Right? It cannot start after x minus I, because otherwise it goes outside of our box. So it can start from 0 to x minus I. Also, this dimension can start from 0 to y minus j, so it's y minus j plus 1. And the last one is going to be l minus z minus l plus 1. So it is the product of these three values. Yeah, it's important to consider this plus 1 because it starts from 0 to x minus I, right? So it's x minus I plus 1, 0, because we have 0 as well. So if we know I and j and l, it is easy to calculate this. And what do we know? We know that x and y and z are up to 2000. So if we brute force we have 2000 plus 2000 to the power of 3, 2000 cubed ways. But there's an easy way to optimize it. I mean, we have an O of, for example, assume that we show the maximum dimension as big D. We have an O of big D to the power of 3, D cubed solution. How can we improve it? How can we improve it to D squared? What do you guys think? Exactly. Great, Wazif. Exactly. We can just brute force, instead of brute forcing on all three I and J and L, we know that the volume of this magical box inside is K. So we do not need to brute force on all the three variables. We can just brute force on I and J, only on these two. We can just brute force on I and J. And if we do that, L will be uniquely determined. Well, first we have to say that if K modulo I times J was not 0, it means that K is not divisible by I times J, so we should continue. In this case, we should continue. This is not okay. Otherwise, L will be just K over Ij. So we do not need an additional 4 for L. L is equal to K over Ij. This way we can just fix I and J, and this way we can improve O of D cubed to O of D squared. And because D is up to 2000 to the power of 2 works well. So this way, by knowing the volume, we can just fix I and J, and L will be uniquely determined, and for each valid I and J and L, we just calculate the value of this product, and we say that ans is equal to maximum of current ans and product of these three values. Right? Because between all the possible choices for I and J and L, we want the one such that it maximizes these products. So if we take a look at our code, at the code, let me show it to you in here. If we take a look at the code, we just see in X, Y, Z, and K, and we just have a for I from 1 to X, J from 1 to Y. If K modulo I times J was not 0, it means that this case is not valid. So we should continue. Otherwise, L is equal to K over I times J. We should also say this: if L was greater than Z, then it means that L doesn't work well. L does not fit into the box. In that dimension, we do not fit in the box. So also this case is not valid as well. So we should continue. And then V1 is equal to X minus I plus 1, V2 is equal to Y minus J plus 1, V3 is equal to Z minus L plus 1. And we say that ans is equal to maximum of ans, and the answer for this specific I and J and L, we want to choose some I and J and L that maximizes our answer. So we just say that ans is equal to maximum of ans and V1 times V2 times V3. And I defined everything as long to be sure that I won't have overflow. And at the end I will see out ans. And that's gonna be all. And I see that someone has messaged me. Guys, I'm sorry, right now I don't read that, but after the stream I will read that and I will answer you. Yeah, brute force initially is D cubed, but with this idea we can improve it to D squared. The whole point is that when we know the volume, by fixing I and J, L will be uniquely determined. So is this one clear as well? Shall we move on to problem F? O of n solution, I don't know what is O of n solution. How do you guys solve it with O of n? I just solved it of n squared or D squared. Yeah, what is your solution? Let me see. We can also get O of n by doing O of factor of k to the power of 3. K is up to, k is a very large number, isn't it? So the number of factors The number of factors is O of sqrt of k, and k itself is n to the power of 3, is n cubed, right? Do you agree with that? How do you determine whether a problem can be brute forced? This is something that you will think of. I mean, you just check that out. I mean, among all the possible ideas, you will check that out if this problem can be brute force, and then you check the limits and see if you can do it in a way that it works. For example, most of times in easier problems, it is possible to use brute force in easier problems. For example, in this one, we have all the constraints to be 2000. We know that we can fix the values of in these 3 dimensions. We know that we can fix that. But we know that it's a bit bad. It's 8 times 10 to the power of 9, which is a bit bad. But we can easily improve that one, improve our solution. How? Because we know the volume, so we instantly think about the fact that we do not really need to brute force on the last one. We just need to do brute force on the first 2. Then we'll find out that, okay, brute force works, and we'll start implementing it. SQRT of k, we have SQRT of a possible divisors, SQRT of k, and k is a lot. That much also works, but it wouldn't be O of n. So I think that the main solution for this problem is like this. But it might be interesting to solve it with a better time complexity. Then you can also solve a harder problem with greater constraints. Right. Okay. Sure. Okay, shall we move on to problem F? If you're okay, react, please. React with this emoji, this reaction. Awesome. Thank you. Awesome. Problem F. You are facing the final boss in your favorite video game. The boss enemy has H health. Your character has N attacks. The ith attack deals AI damage to the boss, but has a cooldown of CI turns, meaning the next time you can use this attack, it's turn X plus CI, if your current turn is X. Each turn you can use all attacks that are not currently on cooldown, all at once. If all attacks are on cooldown, how you do nothing for the turn and skip the next turn to the next turn. Initially, all attacks are not on cooldown. How many turns will you take to beat the boss? The boss is beaten when his health is 0 or less. Well, in this problem, I used binary search. I want to find out if I have X turns, for example, if I have X turns, can I beat the boss or not? Well, I know that for attack number I can harm A sub I, but I can do it every CI turns. So how many turns can I do this attack? If I have X turns in total, if I have X turns in total, how many attacks at most I can have? Yes, exactly. It's sale of X over Ci. It's a sailing of X over Ci. For example, if X is 1, in the first turn I can do this attack. If it is, for example, C sub I turns, I can do only 1 attack. But if it is C sub I plus 1, I can do 1 attack in the first turn and 1 attack in the last turn. So it's sailing of X over Ci, which is equal to floor of X plus Ci minus 1 over Ci. These two values are equal. So sailing of x over ci is equal to floor of x plus ci minus 1 over ci. Exactly. So I can do at most these attacks. And I can do this much. So this is the most damage that I can have for this turn. And because all the turns can be treated as independent, I mean, for all of them I can have this maximum. For all of them I can have this maximum turns. So for each one of them, it's enough to count this value times AI. I can have these many attacks, each one of them harm AI. So I can easily find out that in X turns, what is the maximum possible damage that I can have to the boss, I can do to the boss. And if it was greater than or equal to H, then the answer is less than or equal to X. Otherwise, the answer is greater than X. And this way I can do binary search. And by doing binary search, then I will find the answer. So let's take a look at our code, at my code. This is problem F. I'm just saying that I have low equal to 0. Low is, in the binary search, it's always good to define your two bounds in a way that one of the bounds says something, the other one says something else. For example, I know that low is not possible. I'm sure that with low turns I cannot beat the boss, and I'm sure that high is possible. Okay, so low is not possible. It's not possible to beat the boss with low turns. In low turns, and is possible to beat the boss in high turns. Okay, initially I set low equal to 0 and high equal to inf. I'm sure that inf is defined as 1e11 in here. I'm sure that in 1e11 steps I can do, because based on the constraints, they are up to 2 times 10 to the 5th. So each 2 times 10 to the 5th seconds, I can damage 1. And h is at most 2 times 10 to the 5th as well. So in 2 times 10 to the 5th squared turns, I can beat the boss. So in 10 to the 11 steps, I'm sure that I can beat the boss. So inf is something that is possible to beat the boss in high turns. High is like this. Low is something that is not possible to beat the boss in the low turns. And while they were not adjacent, low, high minus low was greater than 1, I set mid, I see if it is possible or not. If it was possible, high will be equal to mid, otherwise low will be equal to mid. This is the neatest way to implement binary search. Always try to do binary search like this. Yes, also priority queue can work in this problem. Priority queue also works, and yes, 1e13 also works. And then for mid, when I want to check if it is possible, I see sum is going to be the damage that the sum of the damages that I can have to the boss. I have 4 on all of the moves. For each one of them, I say that I add to sum the value of sale of mid over ci. This is sale of mid over ci. Okay, because that's the maximum turns that I can have, and in each turn I can damage a sub I. So I multiply these two values and I add them to sum, and I also always take it minimum to h. I added this because I was worried to have overflow. I was worried that it might be possible that I will have even overflow for long, even if everything is long in this solution. But I was worried that it might have overflow. That's why I keep everything. If it is greater than h, I turn it to h again, because h is enough for me. I don't need it to be greater than h. So if it was greater than h, I will turn it to h again. And at the end, if sum was equal to h, it means that I can damage h, so high is equal to mid, else low is equal to mid. And at the end, high is the least possible value that is possible to beat the boss, because high minus 1 is low, which is not possible, but high is possible. So I will see out high at the end. Does this one completely make sense? So I just do a binary search, and with binary search will crush this problem. When you do a binary search, it's easy to find out how much each move is going to damage And once how much each move, how many turns you can have for each move, and you multiply that by the damage of that move, and you just sum these values of, if this value was at least h, you're done. Otherwise it is not possible to beat the boss like that. Okay, please again use this reaction to find out if you understood it well. Yes, double can be used to avoid overflow, but it is the best if you don't use double. If you don't use double, it is better, because double is a bit problematic. And yes, as KTL mentioned, using double is pretty risky. That's right. It's better if you don't use double. It's worse to use double when you overflow long legs. Awesome. Abhay, congrats. That is great that you solved 7 problems. Okay, so let's move on to problem G. We are going very fast. Feel free to tell me to stop and explain anything again if you needed that. Even if you need the explanation of problem A, feel free to say that to me. I can, at the end, I can get back from the beginning and solve A. Discord link is pinned. So I pinned the message that has the Discord link. You can see it there. The next problem says that let d of n represent the sum of digits of n for how many integers n when n is from 10 to the L to 10 to the R. Satisfy d of k times n is equal to k times d of n. Output the answer modulo 10 to the 9 plus 7. You know, in this problem, my solution was not very easy. But if you had a better solution, you can also say that in here. So let me now tell you the solution. Well, the first fact that helps you a lot to solve this problem, you should first think that when this happens that d of k times n will be k times d of n. So you need to know this equation better. We have to try to know this better. This is so important, that when this happens, when this can happen, well, the important thing is that when you multiply some number by k, if for some digits that digit times k is greater than or equal to 10, these digits, I mean, for example, you have 7 here and you're multiplying by 5. You cannot write 35 in here. You will just write 5 and add 3 to the next digits, to one of the most valuable digits. And that's where you will lose. This is not possible anymore, because you have lost 30, I mean the sum of these digits by times 5. When you have 7 in here, 7 times 5 is 35. So if this one has 7, this one should have 35. But what you are doing, you're just adding 5 here and only 3 to the next digits. So this should never happen. This should never happen that when you multiply each digit by k, that number should not raise above 10. It should not raise, it should not be at least 10. Because if it is 10, you will move one digit to the next one. And obviously the sum of your digits will be decreased. Because for example here, if you have 7 here, on the other hand, you should have 35 in here, so that it makes up. But what you're doing, you're just adding 5 and only 3 to the next digits. So 35 will not be added to your to the sum of the digits of your answer. 8 will be added to the sum of your 8 will be added to the sum of the digits of your answer. 5 here, and at the base case scenario, 3 to the next digits. Right? So that's the main idea. You try to understand this, you try to find out when this happens, and you will find out that all the digits, when they are multiplied by k, they should not become greater than or equal to 10. And that gives you an important idea. And what is that? What is that important idea? That k cannot be greater than or equal to 10. If k is greater than or equal to 10, the answer is definitely 0. There's no number that if you multiply it by k, d of k times n will be equal to k times d of n. Why? Because obviously when you multiply them, this number is not 0. So at least has one non-zero digit. When you multiply it by k, it's obviously this multiplication, because k is greater than or equal to 10, is greater than or equal to 10. So you will lose something, definitely. So if k is greater than or equal to 10, the answer is for sure 0. You can see it here. If k is greater than or equal to 10, the answer is for sure 0. Right? Are you completely okay with this part? If you are okay with that, please use this reaction again. Do you know Neil? Yeah, I've heard his name. Okay, awesome. So that's the first catch on this problem. We are sure about this. Now there's something that we need to consider. You know, we know that, for example, if our k is equal to 3, our number, the digits of our number should always be at most 3 as well. Or maybe it's better to use another number. Assume that k is 2, for example. When k is 2, we know that our digits, when multiplied by k, they should not be greater than 10. So all these digits should be from 0 to 4. And the first digit should be from 1 to 4. The biggest digit, because the most significant digit cannot be 0. It should be from 1 to 4. And the length of this should be at least, the length of the number of digits should be at least L plus 1 and at most R. Because 10 to the power of L has L plus 1 digits, 10 to the power of R has R plus 1 digits. So n should be greater than or equal to 10 to the power of L, and it should be less than 10 to the power of R. So the number of digits should be from L plus 1 to R. So we can say that in here, sorry for the sound, we can say that in here, the number of digits should be from L to R minus 1. So we have one digit here, and in here, the number of digits is at least L and is at most R minus 1. And we know that each one of them have 5 choices. So if, for example, assume that the length of here is L. If the length of here is L, we have 5 to the power of L choices for these digits and 4 choices for the first one, because the first one cannot be 0. If the length is L plus 1, we have 4 times 5 to the power of L plus 1. And oh man, now I see what a bad mistake I made. I mean, this problem could be solved very easier. I used a very hard approach. I got it now. Okay, the next one is 4 times 5 to the power of L plus 2. And so on to 4 times 5 to the power of R minus 1. So that's all. It's like we have 4 times 5 to the power of L to 5 to the power of R minus 1. If we want to generalize it, if whatever k is, digits here can be from 0 to 9 over k. Floor of 9 over k. They cannot be. No digit can be greater than 9 over k. So assume that 9 over k, floor of 9 over k is x, or is x minus 1. I say that it's x minus 1 because these numbers can be from 0 to x minus 1. Sorry. I'm sorry. Assume that it is x. Maybe it's better if it is x. These numbers can be from 0 to x. So we have x plus 1 choices here. And we have x choices for the first one. So it's like we have x for the first bit times the next after it. If the length is L, it's gonna be x plus 1 to the power of L. If it is L plus 1, it's x plus 1 to the power of L plus 1, and so on to x plus 1 to the power of R minus 1. So we need to calculate this value. That's all we need to calculate. Do you agree with this, guys? Again, you can use reactions if you agree with this. Why from 0 to 9 over k? Because I said that each digit, when will be multiplied by k, the result of the multiplication should be less than 10. Or in other words, should be at most 9. Because we should not have any digits to be greater than 10 so that it gives some number to the next more significant digits. If that happens, we will lose the sum of digits. For example, when we multiply 5 by 7, in our answer, instead of adding the number of digits of answer by 35, we will just add it by 8, because one digit will be added by 5 and the next digit will be added by 3 in the best case scenario. So that should never happen. So when we multiply these two, the answer should be at most 9. For each digit, the product of that digit and k should be at most 9. Do you agree with this now? I mean, is it clear now? Yeah, now the question is how to calculate the formula itself. Well, the formula can mathematically easily be solved mathematically. I didn't do that in the contest. I just, let me first show you my code to see what I did. I just implemented a function to calculate that, and the function was relatively complex. I just calculated this function and this function, and this way I calculated the answer. But that's not necessary, because we can also just say this. We can just say that when we have, for example, assume that it is y to the power of L to y to the power of R minus 1. Well, first of all, the idea of prefix sum always helps. If you can solve from y to the power of 0 to y to the power of R minus 1, then you can do the same thing for L minus 1 and subtract these two numbers, right? And this can be simplified easily by mathematically. It can be easily be solved mathematically. It is equal to y to the power of R minus 1 over y minus 1. That's all. It's y to the power of R minus 1 over y minus 1. So this is a mathematical expression. And why is that? Because let's see this number in base y. What is this number in base y? Can anyone say that? What is this number in base y? Can anyone say that in the chats? No. I'm just saying that this number, y to the power of 0 plus 2y to the power of r minus 1, this value in base y, how can we represent it in base y? For example, we have 3 to the power of 0 plus 2 to the power of 1, 2, 3 to the power of r minus 1 in base 3. How can we represent this number in base 3? Can you say that? Yes, this is sum of geometric progression, but I want to say that y it is equal to this. Yes, this is the sum of geometric progression and it is equal to this. I want to just say y this is equal to this. Well, I can say that this number in base 3 is like this. It's like we have r1s. if we write this number in base 3, it's like we have R1s in base 3. Because it's like we have 1 3 to the power of 0, 1 3 to the power of 1, 1 3 to the power of 2, and 1 3 to the power of R minus 1. Right? Also in here, when we write this number in base y, it's like we have 1 y to the power of 0, 1 y to the power of 1, y to the power of y to the power of 2, and 1 y to the power of R minus 1. So it's like we have R1s in base y. Do you agree with this? Again, use reactions, please. Sorry, this reaction. So I'm just saying that this is equal to, no, I'm just talking about these parts. I'm not multiplying it by 2. I'm just saying 3 to the power of 0 plus 2, 3 to the power of R minus 1. Okay, so let me say this. We want to calculate this value, y to the power of L, 2y to the power of R minus 1. Okay. I want to say that this is just geometrical progression, and we can just say that this is equal to y to the power of R minus 1 over y minus 1. Right? Yeah, I didn't multiply it by y minus 1. Yeah, at the end I should multiply it by y minus 1 as well. But I haven't done that already. I just want to prove that this is equal to this. Okay. So I'm just saying that y to the power of 0 plus y to the power of 1 plus 2y to the power of I minus 1 in base y is equal to 1, 1, 1, 1, 1, 1. And it's easy to say that because we have 1y to the power of 0, 1y to the power of 1, 2, 1y to the power of R minus 1. Right? Is it clear now? And I started from 0. I just started from 0. And went to R minus 1. So I'm talking about a very simpler version, which is geometrical progression. If it is clear, please use reaction. If it is not clear, you can use this reaction if it is not clear. Okay, so I'm just saying that when we have this value y to the power of 0 plus 2y to the power of R minus 1, then this is gonna be 1, 1, 1, 1, 1 in base R. And when we multiply it by y minus 1, because we know that, we said that the final number is x times x plus 1 to these powers. So if we call y as x plus 1, it's like we have y minus 1 times y to the power of L plus y to the power of L plus 1 and so on. So our final expression is like this, y minus 1 times this. When we multiply it by y minus 1, it's like all these digits turn into y minus 1. Yeah. So when we want to calculate this number, y minus 1 times this, it is going to be like we have r y minus 1s. And assume that that is x. And what is that? This is equal to? This is equal to y to the power of r minus 1. Why it is equal to y to the power of 1 minus r? 1, because if you add 1 to it, all these numbers will become 0, and the next one will become 1. Because I said that x is equal to y minus 1, so it's the greatest possible digits. When you add only 1 to it, all of them will become 0 and add 1 to the next digit. Then the next one becomes 0, adds 1 to the next digit, the next one. It's like, for example, if we talk in base 3, it's like we have several 2's in base 3. For example, we have R2's in base 3. I'm saying that if you add only 1 to it, it turns into this 0, 0, 0, 0, 0, 1, which is 3 to the power of R. Everything is in base 3. So I'm saying that if you just add 1 to it, it's gonna be 3 to the power of R. So all I'm saying is that this value, y minus 1 times this, is equal to y to the power of R minus 1. That's all. It's equal to y to the power of R minus 1. And it's just enough to say that when we want it from y to the power of 0 to y to the power of r, we can use the idea of prefix sums. First we calculate it from 0 to r minus 1, and then we calculate it from 0 to l minus 1, and we subtract these two values. This way our answer is going to be this. Our answer is going to be y to the power of r minus 1 minus y to the power of l minus 1, which is equal to y to the power of r minus y to the power of l. And that's going to be all. So, and what was y? Y is x plus 1. And what was x? X was floor of 9 over k. So when you got a value of k, if k is greater than or equal to 10, then the answer is 0 definitely. Otherwise you can calculate 9 over k plus 1 and then say that your answer is y to the power of r minus y to the power of l. And this way y is equal to 9 over k plus 1. Is it clear now? Please use reactions like this if it is clear. And if it's not, use this reaction. Now the question is that how to calculate y to the power of r minus y to the power of l. Well, you should, this is a very classic problem. If you want, I can explain it. There are many ways. One of them, for example, is recursive. You can calculate a to the power of b in O of log of b. How? It's just enough to, when you want to calculate a to the power of b, it's just enough to calculate a to the power of b half, floor of b half. Recursively calculate this and assume that this is x. Then your answer is gonna be x times x if b is even. If b is even, then the answer is simply x by times x, because it's a to the power of b half times a to the power of b half. If b is odd, this is going to be x times a, because you have one additional a as well. So yes, easily in O of log of b you can solve that. For a to the power of b is enough to calculate a to the power of b half. For example, if you want to find out a to the power of 7, you first calculate a to the power of 3. For a to the power of 3, you first calculate a to the power of 1, and you know that this is a. And then you take this a, multiply it by itself, and this, because 3 is odd, you multiply an additional a to it. And then you take a to the power of 3, multiply it by itself, and then because 7 is odd, you multiply an additional a as well, and so on. This way, at most log steps, you will solve. For example, assume that this was a to the power of 14. It just takes a to the power of 7 and multiply it by itself. I think you can see these parts and more. It's below my window. But anyway, I'm just saying that a to the power of 14, let me show you this. Let me move myself. I'm just saying that a to the power of 14 is equal to a to the power of 7 times a to the power of 7. Is it clear? So this way we can just simply calculate the power of a number. Yeah, it is called binary exponential. Yes, it is like that. Yeah. Okay. So is this problem clear as well? Okay, if so, we can move on to H, problem H. And before that, guys, let me ask you a question. Let me move on to my YouTube. Have you had a chance to watch these new DP playlists? Problem solving 2000 plus. Hey guys, problem solving. I have added 4 videos. These are 2000 plus difficulty DP problems. Have you had a chance? 2000 plus difficulty. Look at them. Do you have any feedback? Had a 2000 plus difficulty. Look at them. I would love to know your feedback. 2000 plus difficulty. Look at them. I would love to know your feedback. 2000 plus difficulty. Look at them. These are the problems that I tried to be the best problems. These are the problems that I tried to be the best problems. These are the problems that I tried. I'm making videos on that. Also, these are the problems that I tried. I'm making videos on that. Also, these are the problems that I am making videos on that. Also, these are the problems that I am making videos on.
Hey guys, this is Shayan. 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 Hey guys, this is Shayan.
Feel free to tell me if you also need any.
Hey guys, this is Shayan.
Feel free to tell me if you also need any.
Hey guys, this is Shayan.
Feel free to tell me if you also need any.
Hey guys, this is
Feel
Shayan.
free to tell me if you also need any.
Hey guys, this is
Feel
Shayan.
free to tell me if you also need any.
Hey guys, this
Because
is
feel
Shayan.
free to most of them that is
Hey guys, this
because
is
feel
Shayan.
free to most of them that is
Hey guys, this
because
is
feel
Shayan.
free to most of them that is
Hey guys, this
because
is
feel
Shayan.
free to most of them that is
Hey guys, this
because
is
feel
Shayan.
free to most of them that is
Hey guys, this
because
is
feel
Shayan.
free to most of them that is
Hey guys, this
because
is
feel
Shayan.
free to most of them that is
Hey guys, this
because
is
feel
Shayan.
free to most of them that is. Oh. Yes, I'm sorry for this. Because I made my laptop mute, I thought it will be muted for you as well, but it's not. Yeah, yeah. I taught you recursion with live example. Yes. Yeah, I just said that there is also a spreadsheet. I sent you the link that if you want, you can also check out that spreadsheet and just make a copy of that one for yourself and solve them. And I just wanted your feedback about this DP playlist if you had a chance to check that out. There are dynamic programming problems with difficulty 2000 plus. So feel free to tell me if you have any feedback and if you need anything else from its cover. For easy problems, I just think, but for harder problems, I use paper, yes. For example, in this contest for the last problem, for problem H, I used paper. Okay, so I think now we're ready to move on to the next problem, H1. This problem says that Alex has a grid with n rows and m columns consisting of dots and hashtag characters. A set of hashtag cells form a connected component if from any cell in this set it is possible to reach any other cell in this set by only moving to another set, another cell in the set that share a common site. You want to make one row on one column all hashtags in a way that you will maximize the size of the maximum connected component with hashtags. You have to say that what is that maximum value. Well, for this problem, I used a very hard solution, but again, I found out that it could be solved simpler than that when I was solving H2. In this problem, let's first use DSU. I use DSU. But you could also do it offline. You could also do it offline with a DFS. Both works. For each one of them, for each one of these hashtags, try to find out in which connected component they are. I mean, assign a root to them, assign one of them as the root, as their candidate, and just keep the size of that one. Okay. Then try to, for each row, for example, for a row, we want to find out what is the answer if we consider this row. Well, I'm saying that if you consider this row and you want to make it hashtag, well, first of all, the maximum size should use this row. Otherwise, it was pointless to make this row all hashtags. So you can always assume that it is enough to find out the size of the connected component, including this row. So you need to find out, if you make this row into hashtags, what is the size of the connected components connected to this row. You don't need to worry about the rest of them, because if you change this row, then definitely this row should be in maximum. Otherwise, your movements was pointless, right? And the optimal answer will be calculated somewhere, because there is a row that is in your final answer. There is a row or column there, so the answer will be calculated there. So I'm saying that if you choose a row and you want to find out what is going to be the size of the connected component, including this row at the end, you can just simply say that this row has intersection with several connected components. And I define an intersection as all the connected components which are in these three rows, in the previous row, or in this row, or in this row. We have three rows. Any connected components that has any cell in these three rows, they will be connected to my final connected components. So I just need to find out, for each row, I need to find out what is the set of all of the connected components in these three rows. In these three rows, I just need to find out the size of all of them, and I need to add them up, and I also need to add up all the cells with dots in this row. So in this row, I should find out how many dots do I have, because they will be turned into hashtags. And also, any connected component that shares a cell with one of these cells in these three rows, they will be connected as well. So it's like, for each connected component, I know that each connected component covers an interval of rows and an interval of columns. I'm saying that each connected component is in an interval of rows and in an interval of columns. I mean, it might look something like this. I mean, it can look however it wants. But anyway, it is in an interval of rows and in an interval of columns. I'm saying that it is not possible for a connected for connected components to be, for example, in these rows and in these rows, but there's no cell with hashtag in the middle of them. There's no cell in that connected component in this middle row. This is not possible. So I'm saying that if you consider all the rows that intersect with your connected components and all the columns that intersect with your connected component, most of them are continuous. Do you agree with this? So I'm just saying that for each connected component, all the rows that have intersection with that connected component are continuous, and all the columns that have intersection with that connected component are also continuous. If you're okay with that, please again use this reaction. This is very important, especially in H2. Especially in H2, it is very important. So when I want to find the answer, I just know that, okay, these connected components intersects with these rows and these columns. So I need to add this connected component, the size of this connected component, to the answer of all the rows from one row before the starting row of this connected component to one row after the ending row, latest row of this connected component, and from one column before the first column of this connected component, by one column before, because they also share a side with this connected component. For example, if you make this row into hashtags, we know that if you turn this column into hashtags, we know that in the next column there is a cell with in this connected component, so they will be joined. So you can move for one additional column as well. So you know that you should add the size of this connected component to all the columns here and all the rows in here. So you have to add an interval, which is a very easy prefix sums problem. Also, prefix sums is not necessary in H1 as well. You can just have a 4. That would also work. Amortize, the order will be at most n times m, because if you have a 4 on all of those rows and all of those columns, you had a cell in that rows and columns. So all your iterations will be for a cell, and each cell will be counted once. So in total amortized, you will have O of n times n. Okay, so I'm just saying that the answer of these columns will be added by, if the size of the connected component was x, the answer of these columns will be added by x, the sum of these rows will be added by x as well. And at the end, it's just also enough that for each row and column, we just also add the number of dots in that row or column. That is also easy. I mean, whenever you saw dots, just add that specific row, the value of that specific row by 1. That's all. And this way, at the end, you can find the maximum value of a row or column, and that is going to be your answer. Is it completely clear? My code, as I said, in my code, I used a very harder solution. So it is not exactly like this. As you can see, my solution was way harder and way longer. But when I was solving H2, I understood that this part could be solved very easier. It was just enough to say that we need to just, it's like we want to merge several components. I will show you one code as well. I will show you a code of maybe another person. I'm just saying that, but let me first explain this. I'm just saying that when you make a row into all hashtags, it's like you are going to merge several connected components. You're merging them. So you need to know the sum of their sizes. And for that, I'm saying that, okay, for each connected component, you know that it is in an interval of rows and in an interval of columns. So they cover a continuous interval of rows and columns. So you need to just add the size of it. If the size of it is x, you need to add the value of all these rows by x. You can move one further as well in each direction. You should add these by x, and also you should add these by x, the answer of these by x. And at the end, the answer of a row or column will be this value plus the number of dots that they have. And for that, that is also easy. Whenever you saw a dot, you can add 1 to the answer of its row and its column. Right? So, are you okay with the general idea? Please use reactions again if you're okay with that. And let me also show you a code. As I said, my own code is a bit complicated. Let me show you this code, for example. Let's see what he has done. Let's see what is the solution of this person. You know, as you can see, this person also has tried to do this. For each row, he has a 4 on all of the connected components in that row, and he sums up the size of their connected components. So he counts that how many dots that row has, and adds to it the size of all the connected components intersecting with that row. And that's all we need to calculate. I mean, we can just say that for each row, if you turn it into all hashtags, you just need to find out how many dots do you have. They will all be in your connected component because they turn into hashtags. Also, for each connected component intersecting with this row, you should sum up their sizes. An intersection can be just if they are even in one row below or one row above our current row. That also works, that also counts. And we can just do this. And my solution, as I said, I just wanted to say that because each row, this fact is especially important in H2. Because each connected component is in a continuous rows and in continuous columns, for each one of them you should add the answer of some interval of rows and some interval of columns. And this way you can find out the answer. Is it clear? So in which range of problem in div2 you actually need to use paper? Maybe from problem E or D in div2. Guys, if you're okay with that, please use this reaction again. If you're not, use that other reaction. Shall we move on to H2? Is this one clear? It's easy. Yeah, I also use DSU. You can both use DSU or you can also use DFS as well, because you don't need online merging. You just can do it at the beginning. Okay, so if you're okay with that, we can now move on to problem H2. If you feel free to ask me any questions if you have any questions about this. In H2, it's the same problem, except this time we can choose a row and a column and turn them into hashtags. So we choose a row and we choose a column and we turn all of them into hashtags. And we need to find out that what is the maximum size that we can have. Well, in this problem, that fact that I said is very important. As I said, again, for each connected component, I know that it is in an interval of rows and in an interval of columns. And there is an interval of rows that I show with red, that their value will be added by size of this connected component. It is one row before the first row, to one row after the last row, and from one column before the first column to one column after the last column. Is everything clear so far? If you didn't understand completely what are these red lines and blue lines, feel free to tell me. You just add the parts to the accumulator for the row and column. Yes, exactly. When I find the connected parts, I just add its sum to all the rows and columns that it includes, and also one row and column further. I mean, it's okay if they just are in the next row or in the next column. That also works. So yes, I will find all the rows and columns which include these connected components or are adjacent to these connected components. For example, in here, if this connected component is in here, we can have one further in each direction, and these rows and columns are all the rows and columns that if we choose them, they will have these connected components in them. Do you agree with this? Is it clear? So first, again, I do what I did in H1. I just add these columns and add these rows by X. I just add them by X. But there is one important thing. It's similar to inclusion-exclusion principle. When you choose some row I and some column J, you will calculate this connected component twice, and that's not good. So I'm saying that when you turn row I to all hashtags and column J to all hashtags, and if they both have this connected components, you will count it twice. And for which I and J's you will calculate it twice? For all I and J's in here. So it's like a two-dimensional prefix sums. I have a video that I explained prefix sums, one-dimensional and two-dimensional prefix sums. If it helps, you can watch that out. But all I'm saying is that for these cells, I make a two-dimensional array, and for these cells, for these I and J's, I should decrease all of them by x. I should decrease their rest by x, because these connected components will be calculated twice for these rows and these columns. So I should subtract them once. And that's all I'm gonna do. So again, for each row and column, I have an answer. I just have an additional two-dimensional prefix sums for which I need to just decrease a rectangle by value of x. These are several 2D prefix sum queries, prefix sums queries. And then this way I can update them, and then I can find the best values of for I and J. At the end, I can just print them out. Is it clear, guys? If it is clear, please again use this React. Ariane or Ariane, I'm not sure if you're with me, but if you're with me, thank you. Yeah. So, and yeah, my code is like this. I just merge everything. I use DSU. I merge everything, and I just whenever I had these intervals and I update them, I move them one step further, and I just need to add, other than adding for these set of rows and this set of columns using prefix sums, I also add prefix sum to this interval, to this rectangle inside. This is a two-dimensional prefix sums. And then at the end, for each I and J, I can easily calculate the rest of I and J. I should subtract that value that I calculated in prefix sums, two-dimensional prefix sums, and add for each row and column the values I have. And this way I can find out the final answer. UTL it with the same solution? I'm not sure why, if it is really the same solution. What will be the logic of subtracting? Yeah, sure. The logic of subtracting is this. You know, I'm just saying that when you have these connected components, this is calculated in row number I. It is also calculated in column number J. If you choose row I and column J, this connected component will be calculated twice. Once for this row and once for this column. But you need to calculate it only once, right? You need to calculate it only once. So if your selection is an I in this interval and an J in this interval, you should subtract it by x, because you add x twice. So it's like you're subtracting x from a rectangle in here. And that's gonna be all in this problem. So you just subtract that and add these intervals, and also you take care of dots. You see that in row number I and column number J. Using these prefix sums, you can easily calculate that as well. How many dots do we have? Add those dots as well, and that is going to be your final answer. Is it completely clear? If you have giant rings of hashtags, doesn't this mean you need to subtract x? No, no, no. I do not have a 4 on all the i's and j's. I do not have a 4 on all the i's and j's. I use prefix sums. I recommend you to watch the prefix sums videos. I just add and subtract 4 values. If I want to change a rectangle, I just add and subtract only 4 values. And at the end, by prefix sums, I will update all the values so that all the cells in that rectangle will be changed. You need to first get familiar with two-dimensional prefix sums. Maybe I can send you the link of that video as well. Sorry. Prefix sums. You can see the video of prefix sums here. I need to open my live again. Okay, I muted it. Yeah, you can see it here. Yeah, I used prefix sums, and using prefix sums you can easily find out the answer. Is it clear as well? Please use these reactions again. And guys, feel free to join our Discord server. You are more than welcome there, and we can discuss there. We will have duels there. You will understand more soon. Yeah, try to upsolve contest. Try to solve at least one of the problems that you didn't solve in the contest, always. It is good if you upsolve the contest. And other than that, you can solve rating-wise problems. I think don't overdo it. I mean, if a problem is really hard for you, is not at your level, you can just ignore that. But if in a contest you have a problem that you could really solve, you have the knowledge to solve it, but you didn't solve it for any reason. For example, you didn't have enough time, or you didn't come up with the correct idea in the contest. Try to upsolve them. That is very important. Contest and upsolving the contest afterwards really important. Really helps you. Like 80% of H2 after watching. Thanks for listening. You're welcome. So happy that you know that. If you need, you can maybe watch the H2 part again. I will also add timestamps to the live stream so that you can watch any part you want. So if you need, you can watch that again. And if you need me to explain any part again, feel free to say that. Or if any other problem from A to H2, if you need any problem, feel free to tell me that. And again, guys, for this message, I will try to answer them after the live stream. Oh, my description says global around 26. It wasn't updated. Sorry for that. I will update that one. That is great. AARY. I don't know how to pronounce it, but that is great. You add every component of column and row, and yes, exactly. I also, whenever I saw a dot, I should add 1 to the answer of that row, and add 1 to the answer of that column, and subtract 1 from the answer of this row and column. Because if you choose exactly this row and this column, these dots will be calculated twice. So when you have a dot, it's enough to add 1 to the row, add 1 to the column, and add -1 to the pair of this row and this column, because for this pair, that will be calculated twice. Thank you very much. I hope we will have a good result in the World Finals. Wish us luck in the World Finals. It's gonna be in September, and we should really train for that as well. Thank you very much, guys, for joining. It was nice to having you again in this live stream. Feel free to tell me if you want videos from anything, live streams about anything. I would love to help you more any way that I can. Yes, I'm participating in ICBC this year. Yeah, we have a good team with Colin Gallen and Sam Lee, and we're gonna participate. Let me make my video bigger. Yeah. Wish us luck, guys. Thank you very much. Thank you for joining. See you soon. Hope to see you in the next live streams as well, and in the Discord server and anywhere else that we can see each other. Thank you very much. So see you in the next videos, guys. Thank you very much.